Assalamualaikum warahmatullahi wabarakatuh, and very good day. My name is Muhammad Iswandi bin Ishaq. Today I will present a paper on design and performance of a new type of boiler using concentrated solar flux. As introduction, a solar energy boiler, also known as a solar thermal boiler, is a device that uses energy from the sun to heat water for household or industrial use. The system typically consists of solar panels, a collector, and a storage tank. The solar panels, also known as thermal collectors, are typically made of a material that absorbs the sun's energy, such as metal or plastic, and have a coating that enhances absorption and minimizes heat loss. The absorbed energy is converted into heat, which is transferred to the fluid flowing through the collector by conduction and convection. Objective of the experiment is to provide experimental results and a proof of concept for a solar boiler where concentrated solar radiation is received on a main solar receiver to operate in boiling mode at the level of the solar receiver without intermediate heat transfer fluids, and also to present a thermal model fitted to the specific conical geometry of the solar receiver to estimate the efficiency of such a boiler and its potentials when using the concentrated downward vertical solar flux and operating under different boiling conditions. From the experiment, we can summarize that the experiments were conducted for an inverted conical receiver under a film boiling regime. The experiments validated the theoretical model of film boiling with a conical receiver in order to reduce the number of CO2 emissions associated with industrial boiling. The design of a new solar boiler operating with concentrated solar energy has been proposed and studied in the present work. A lab-scale solar boiler was built to show the feasibility of the concepts through experiments, and a thermal model was developed to study the efficiency of the solar boiler under different boiling conditions. As we can see from this illustration, the solar boiler in this study used the conical receiver without intermediate fluid. From this experiment, several peculiarities or several qualities distinguish this new design from conventional boilers. Number one, the use of vertical heating downwards from a receiver placed on top of the boiler. The conical shape of the receiver oriented upside down and submerged in the liquid. Number three, the solar receiver has a conical cavity on top where the vertical solar flux is received and its lower surface is submerged in boiling fluid. The direct use of solar energy with optical concentrating facilities for boiling without intermediate heat transfer fluids, and the study of the unconventional film boiling regime at elevated receiver temperatures, which spaces the boiling fluid from the surface of the receiver. And lastly, the model was validated by the data collected and showed good consistency between predictions and experimental results with an average error of 3.79% for temperatures and 2.08% for vapor mass flow rate. That's all from me. The paper was the research was done by Dylan Longfic, Regis Olive, Quentin Falcos, Emmanuel Gillett, Claude Leman, and Aras Ahmadi from France, from University de Toulouse, France. That's all from me. Thank you very much.